Following on from the previous two videos, we are still on the quest to try and find out the area underneath this graph. So we are still trying to find out the area underneath here. So we could easily integrate this when we have an x and then e to the power of minus x squared. We could easily integrate this, but without the x, we just don't have enough knowledge to try and integrate this. So currently, we don't have enough knowledge to integrate this. We can easily integrate this, but currently we don't have enough knowledge to integrate this. So now let me just use history to make a comparison. So if we want to make if we want to work out the volume of a sphere, we could easily use calculus to come up with this formula. So the formula for the circle is given by this. By right, it should be this. But let's just keep it simple. So half of a sphere. So half of a sphere is us really summing up. Remember, we need to sum up all the disks from 0 all the way to R, from 0 all the way to R. So we got to revolve this 360 along the x-axis. So we need to sum up all the disks. So when you look at, we need to sum up all the disks from 0 to R. Well, if you look at this, let's say if you look at this particular disk here, the height here is given by this. So when you revolve it 360, it would give you the area of that one particular disk. So the area would be, hang on, pi r squared. But then we've got to put this into the r here. Okay, so that will then take us to here. So remember, we are only concentrating on half of a sphere. So by right, we should do it from negative r all the way to positive r. But let's just keep it simple. Let's just do it from 0 to r here, from 0 to r here. Well, the half of a sphere is given by this thing here. Okay, so we would just follow our normal routine, and then that would then take us to well, half of a sphere is given by this, so a whole sphere is given by this. The point I'm trying to make here is that by using calculus, we can easily work out the volume of a sphere. But back in the olden days, they didn't know calculus, so hang on. So to work out the volume of a sphere, we could easily use calculus to get to the volume of the sphere. But back in the olden days, they did not know calculus, so they would use this really complicated method, which you have to look up. To work out the volume of a sphere without calculus, they would put the sphere inside a cylinder, and then they would have some sort of cone inside a sphere inside a cylinder, if that makes sense. So here you would have a cone here. Okay, you would have a cone here, and blah blah blah. You've got to look this up for yourself. But they managed to work out the volume of a sphere without the need, without the knowledge of calculus. So what I'm trying to illustrate to you is that we are trying to work out the area here, but in order for us to integrate this, we need to take this root here. By right, we should take this root here, but at the moment we don't have this knowledge here, so we have to take a much harder root. So we are going to try and find out the area of this by taking a hard root. So just similar to this. By right, to work out the volume of a sphere, by right we should use calculus, which would be much easier. But without the knowledge of calculus, we would need to use this method here. But the point that I'm trying to make here is that we need to take this root here. We need to take the hard root to get to the answer. So the point I'm trying to make here is that we are trying to find out this area here. We cannot take this root because we don't have enough knowledge. We have to take the hard root, and eventually we can work out the area of this. This area here is given by we would need to take this root here. We cannot take, well, yeah. So we need to take this root here, and I will continue in the next video.